Hello students, welcome back. So now I will show you central limit theorem and I will demonstrate the central limit theorem through a program. If you recall, what the central limit theorem says is this, that no matter what the original distribution of data is, the distribution of the sample mean, it will always tend towards the normal as the number of samples they increase. Usually the number of samples they go like 30 or higher, and provided that these samples, these 30 or higher samples, they are independent and they're identically distributed. What it means is this. So suppose this is my original this is my original population right here, and let's say I pick up, in this case I'm picking 30 samples. So in this particular instance, my mean value is 2, almost 2, and my standard deviation is almost 2 for this particular distribution. So if I pick up, let's say, 30 samples and I calculate the mean, pick up another 30 samples, calculate the mean, and I keep doing this thing. Okay, and I do this thing maybe 500 times or maybe 10,000 times, then at the end, when I plot the mean of all those samples, it will look something like this. This will be the distribution, and as you can see, the distribution in this case is a normal distribution. That's what it says. So the first thing I do, import my numpy, import matplotlib library, and I'm also importing scipy. This will allow me to import gauss kde, so this will help me with visualization. And now I set up my random seed. This will allow me to reproduce my results. So let's start with the population. I create a population. In this case, I'm creating an exponential population. And my population, original population, it has a mean of 2. In other words, standard deviation is 2. And I'm creating 100,000 points in this population. So let's say my n equal to 30. In other words, I'll be picking 30 samples from this population right here. Then I create my figure size, let's say it's 12 comma 5. Then I'm plotting a histogram. So I'm supplying the population. And in this case, I'm also specifying my bins. I want 40 bins. Then I'm generating X points. So X, basically I'm saying that over here, this particular command, what it does, it generates 500 points from 0 to the population maximum. Whatever the maximum number, whatever the size of your population is, it's going to generate these 500 points from here to up to here. Okay, and then I plot this curve right here, and then I'm giving it title. So let me just show you. When I plot this, this is my population right here. So this is how my original population looks like. It goes from 0 all the way up to this number right here. Okay, and you can see that it puts a little title over here, puts a standard deviation. Okay, after this, now I do the sampling distribution. So I take the sample mean. In this case, what I'm doing, this particular piece of code, it actually runs 1000 times, and it takes n samples. In this particular instance, it's taking 30 samples from the population, and each time it takes a sample, it calculates the mean, and then the mean is stored inside this sample means right here. This one runs 1000 times. So now your sample means is going to contain 1000 entries, 1000 different elements. Each element would be the mean of those 30 samples. And then I plot it. So I give the sample mean, I specify my bins, and then I specify my X value. X is going to be the minimum value of your sample means to the maximum value. In this case, I'm generating 500 points right here. So I plot it, and you can see that this is how your graph looks like. And look at the graph. It's almost like bell-shaped curve right here. Okay, and this original distribution is exponential distribution. You can see that it's more skewed towards the right hand side, and but your the according to the central limit theorem, this should be a bell-shaped curve, and you can see it is a bell-shaped curve. Let's change our population now. So I'm going to come over here. I'm going to change the population to something else. Let's come over here. Let's say my population is now a uniform population. Let's run this. So wait for it, and there you go. And look at this. This is interesting. So in this case, my original population is a uniform distribution right here. You can see that. Okay, but when I'm taking samples out of this, okay, like in this case, I'm generating 30 samples. I mean, look at the sample and look at the your shape of your distribution curve of your samples. It is bell-shaped curve. All right, let's do another one. Let's say I change my population now to something which is skewed. Sorry, with the bimodal. That will be this right here. So this is a combination of normal and normal. Okay, this is bimodal. Let's run this and let's see what this one does. And wait for it. And there you go. So this is my original population right here. And as you can see, this is bimodal. And I'm taking 30 samples from here. As I'm taking 30 samples and I'm calculating the mean of that, and look at that. The mean of this sample is 5. And it is showing, the distribution curve is showing normal distribution curve right here. You can see it's almost like a bell shape. I wonder, what if I change the sample size? Let's say I change my sample size to 2. Okay, come back over here. Let me just comment these ones out, and let's come over here. Let me uncomment this part out, and let's start with the 2 sample. Let's see what that does. And look at that. This is not really normal distribution yet, but if I increase the sample size from 2 So let's say I increase that from 2 to, let's make it 10. Okay, let's see what that does. You will see it will approach towards Gaussian distribution. There you go. You can see that it's reaching, it's almost approaching that bell-shaped curve. Let's do one more. Let's change that to from 2, sorry, from 10 to make it maybe 20. Okay, and let's run this. And there you go. You can see that your original distribution is exponential distribution is skewed more towards the right, but your sample means, when you're taking the distribution of your sample means, you can see that it's almost like it's very close to your bell-shaped curve. So I hope this central limit theorem, it helps you clarify what's happening over here. And thank you.